Okay, so our next speaker is Mr. Baiji He. He helped develop the real-time bidding system and the big data infrastructure at Deep Forest Media. And his talk today is Big Data for Small Startups and Beyond. So please welcome him.
Thank you. Thank you. I want to thank everyone for staying here and listening to me instead of going to the wonderful lunch. So my talk today has a big and small in the title, Big Data for Small Startup and Beyond. So we started this company, Deep Forest Media, 2 years ago, and the goal is to break into the online marketing, online advertising industry, and we do that with the power of big data. And so I'm going to share our experience on how to leverage the power of big data and be smart about what we do about big data, because we are a small startup. We cannot afford to have thousands of servers and do whatever we want. So we want to do everything as efficient as possible and slowly scale the things out. Okay, so here's my background. Currently, I'm a director of data engineering in Rakuten Marketing. It is a division of Rakuten. We mostly are in the United States and Europe. And we do online marketing. Does anyone know about online marketing? Yeah. So this is what big companies like Google, Yahoo, Facebook, they do. 90% of their revenue is from advertising. And they have a huge access. I mean, a lot of users go to their site so that they can place ads on their site, and they can help advertisers to reach their audience. But we do something differently because we don't have a huge site. We do something called real-time bidding, which I will mention in the next slide. And so so Rakuten Marketing acquired our company, Deep Forest Media, just this March. And I was the employee #1 in Deep Forest Media and chief data architect. Before that, I worked in Yahoo Strategic Data Solutions for 6 years, focusing on user targeting, like behavioral targeting, and optimizing advertising spends. I was early adopter of Hadoop, even as early as 2007, before they were open source. So because Hadoop was developed in Yahoo, so I had the privilege to use it in the early age. Okay, I also graduated from Tsinghua University, China. So what do we do in Deep Forest Media? We are an advertiser platform, and we want to help advertisers. For example, Sephora or Toyota, they want to reach their customers. They want to advertise. Traditionally, they can advertise on TVs or radio, but in recent days, they can advertise online, and there are many channels for them to do that. There are search, there are social media, and there are many websites because many websites, they have a lot of audience, so they can sell their space to place ads for the advertiser to help them to reach their audience. This is a great way to help the advertisers to do advertising, because it is very efficient, because the programmatic and the real-time bidding platform in behind, we can target user very specifically, and we are not going to place irrelevant ads to users. So this is a very powerful tool, and we also do it cross-device, meaning the user can use laptop, can use a PC, can use a mobile, iPad, anything. But how do we know the user, who browse a website on his PC is the same person who also go to the other website on his mobile phone? So that's cross-device technology in behind. And we also do that cross-channel, so we do it not only for website, but also for mobile apps. And so in the short period of less than 2 years, we have less than 10 engineers, and we build this platform. And most of them are leveraging the open source big data technologies. And a lot of technologies are proven by bigger companies like Facebook, LinkedIn, Twitter. And so we start from small. We build our servers on AWS, Amazon AWS EC2, but we don't use their managed service. We chose to use open source technologies. So we install these services or softwares on those bare machines. And right at the beginning, we already have a lot of data, because once we connect to, there's Ad Exchange. So Ad Exchange is the supply side or the publisher side platform. They gather all the websites from publishers, websites, apps, and they sell those ad opportunity in real time. So they will send those requests to us, and we have to respond within 100 milliseconds. In that 100 milliseconds, we have to solve huge problem. So we are basically matching, like there are billions of users, and there are millions of websites or apps, and we have to figure out what's the best app to show to that specific user in that context. And we have to also do pricing optimization so that we're not overpaying for the ad opportunity. And so we have to do a lot of machine learning in real time. And these are the challenges we are facing. So velocity is what I just mentioned. We have to do things very quickly. And variety, we are doing real-time bidding. Like we have auction data and we bid, and then subsequently we also do traditional online advertising analysis, like clickstream analysis. So the events will go through funnels, like impressions, clicks, conversions, and we have SDK data to check mobile events, third-party user data. And so there are many different kinds of data. And then we have to use all of them. And the volume we are digesting is, in the beginning, is already terabytes per day. And because we want to be efficient, And also because we want to be good at what we are doing, so we choose to use many different, here I mentioned database, but there are really technologies related to big data, and we use different technologies for different requirements. Yeah. So here's what the whole feedback loop. The edge servers are just the servers we developed to take in HTTP requests, take in the bit requests and respond and bit, and also tracking servers. And then all these data are flowing into our big data infrastructure. There are many terminology or terms here. And then with the help of big data, we can do a lot of we can develop a lot of data products, including like retargeting, cross-device, fingerprinting. And we need to control our budget, how we spend a budget, how do we spend it evenly, and do optimization on a lot of things on like user targeting is a kind of optimization, and also pricing optimization, and what kind of ads to show to the user. We call it dynamic creative optimization. Also, as with any other industry, we do prediction, reporting, and analytics. So, and I don't have a lot of time to cover all this, but so forgive me if I'm giving a too general talk, but I'm going to go over some of the technologies that we are going to use, we've been using. The first one is, so some said 90% of the work in data science is to collect the data and clean the data, right? So in the early stage, we started to use Flume next generation. So it's very distributed, and the good thing about it is configurable. It has a lot of components, like you can have different types of source, listening to HTTP, listening to files on S3, basically a storage system, and it can listen to the log files in the servers, and then it can have different channels. Some reliable channel, a file channel, some unreliable channel, but high performance memory channel. And it has sync to storage data, store data in different places, including Hadoop file system, Kafka, HBase. So it is a top-level Apache project. And so the good thing about open source technology is there are a lot of developers contributing to it. So whenever we have problem, we can go into and look at the source code and try to fix it. And also we will get help from many developers. And so this is great. This is why we choose open source technology. And then later, starting this year, we started to use Kafka together with Flume because two reasons. So Flume is a very general purpose message queue. It's distributed, high throughput. Can accept millions of requests, millions of messages per second. But we have a real use case is we want to have multiple consumers to pull the data in real time. And they will do different things, and we want them to pull the data from the single source of truth. And some of them do streaming processing, some of them persist data into storage like Hadoop file system for later batch processing. And some are just streaming the data to different application servers. So that's very important because we use a lot of language in our stack. We are big in C++ and Java, and also Golang. We use Scala in Spark. So Kafka is really good that it has API in many languages. And then I'm going to talk about the data format. This is actually more important than many people think. So we chose not to use JSON. We use a data format with schema. So when you use this data, when you pass the data through one system to the other system, you have to define a schema. So that makes the data clean from the beginning. And it also has very good serialization. So it's very compact when the data is in the pipelines. And it supports schema revolution. That's huge for ongoing, evolving system. So it works very well with all the big data technologies, Hadoop, Impala, Spark. Also, Parquet is good for doing analytical processing. So here are the technologies we use for doing batch pipeline. In the beginning, we use Hive and MapReduce, which is used by very large companies, but is kind of slow because MapReduce is storing all the stages in disk. So that's, and also it's not a general DAG processing framework. So later we are switching to Spark, and we are quite happy with it. And Impala is a database engine on top of Hadoop file system. It's written in C++ and developed by Cloudera. And we use it for queries, and we use it even for ETL, like transforming the data. In the real-time pipeline, we have Spark streaming, of course. So it's very good at micro-batch processing and can aggregate and do windowing operation. And then we chose not to use we chose not to use Storm because we didn't want to set up a different cluster. Instead, we use Flume Interceptor because we have a Flume infrastructure already. So it can do simple event transformation and cleaning and validation. And when the streaming has to be very fast, we use Golang to write our own stream processing logic. So that's even faster than Storm or Flume Interceptor, but it's very customized. In serving data, we use, we recently experimenting with MemSQL. It's very good, hybrid, can do a transactional workload and analytical workload. It's distributed in-memory database. Vertica is used by reporting, supporting the dashboard. And Aerospy is for key value lookup. So during real-time bidding, we want to know what is the profile of this user, we go to Aerospy. And for something even faster, we have code and embedded database at RocksDB. Okay, I've already mentioned Impala, Vertica, Spark. So we use all of them to do analytics. In reporting, we have custom dashboard using Vertica, and it's very multi-dimensional. You can use it for slice and dice and roll up drill down. And we also use, we offer Tableau reports to some customers. Okay, and monitoring, this is related to big data because we want to know what the system is doing. And so now we are using InfluxDB and Grafana. I think people here are quite familiar with it. Okay, and these are the systems we are not using it yet, or chose not to use, but later we may change our mind, who knows. Okay, so we are actively hiring data infrastructure. We are based in San Francisco, San Mateo. We are based in San Francisco Bay Area. And we are hiring data infrastructure, data integration engineers, user data service. We have a problem, we need to tackle the problem of cross-device, content recommendation, optimizations, etc. So basically machine learning engineers. And, okay, yeah. And questions? Mm-hmm. Yes, that's because we already have Aerospike and MemSQL. So for key value lookup, because Aerospike is very good, is low latency, but for like SQL-like analytic, MemSQL is very good. It has a very good connector with Apache's Spark. So these two are, and also this guy has better performance than Cassandra. That's why we really like them. In the very beginning of our age, we try to use HBase for the user data store, but it's not fast enough because we have a very tight latency constraint. We have to respond back to the exchange in tens of milliseconds. And in that window, we have to do a lot of things. So that's why we choose very fast NoSQL database solution. And sometimes we hard code them, develop tiers of caching layer, and with embedded database. That's yeah, very specific to our problems. Yes. Right. So the question is, in terms of data, do we make any piece of data available to research? Yes. Yes, we do. So the way we design our big data system is as soon as the data lands in our Hadoop file system, it's available for analytic workload or processing. And also, you can use Spark streaming if your machine learning algorithm can be fit into a Spark streaming. You can directly read the data from Kafka. And because we use a specific data format, Avro, so all our data has a schema. So so all our data scientists won't be dealing with messy data that much.
Okay, so this is the end of the talk, and thank you.
Thank you.